Welcome everyone. Today we're going to be covering lesson 1.1 of Precalculus, which is called Change in Tandem. So the first thing we're going to talk about is some vocab, specifically what is a function. So a function is really important in both precalculus and calculus, and it's defined as a mathematical relationship that maps a set of inputs to a set of outputs, or x values to y values, in such a way that every input only has one singular output. So if I input a 1 and I get out a 3, every time I input 1, I'm going to get out a 3 every single time. So I'm using inputs and outputs, x values and y values interchangeably, and that is because they are interchangeable. So an input, which is typically an x value, we call the independent variable, and the output, which are typically our y values, we're going to call our dependent variable. You're used to graphing things on an y-axis and an x-axis. Same kind of thing. We have an independent axis and a dependent axis. We just might change what those are called. So really nicely here, we might use other variables in those cases, depending on what we're trying to model. If we're trying to model height over time, we might use h and t. If we're trying to measure how many miles we travel per hours, we could use miles as our dependent and hours as our independent. How we specifically use functions is through this idea of function notation. So this is a way for us to define variables that are specifically our input and specifically our output. Typically we use f of x, you see f parenthesis x, but sometimes we might use our other variables like h of t. What this basically means is that the inside variable, the variable inside the parentheses, is your input, and the variable outside our parentheses is our output. This does not imply multiplication. So let's try to identify what our inputs and outputs are in a question. So we have w of x is a function where w is the amount of water in a pool measured in gallons, and x is the length of the pool. What does the independent variable represent? Well, if we look at the function notation itself, we have w of x, which means that x is our independent variable. And x in this case is defined as the length of the pool. So the independent variable is the length of the pool. What does our dependent variable represent? Well, our dependent is the one outside of the parentheses. In this case, it's the w, and it says w is the amount of water in the pool. In the pool. Perfect. So function notation is what we generally use, but when we see functions, they can be expressed to us, they can be shown to us in 4 major ways. And those ways are verbally, analytically, numerically, and graphically. Those are very fancy words, so I also want to explain what they are in kind of a layman kind of way. So they could be explained to you with words in a sentence like the one we just did was, with equations, which is arguably the most common, with tables, like a table of values, and with graphs of the curves that these functions would create when graphed. And we're going to be using all 4 of them in both precalculus and calculus. So it's really important to be okay and comfortable with seeing functions in all of these different ways. So let's go over more vocab. We're going to have quite a bit of vocab in this lesson. So increasing. We say that a function is increasing if when the input value increases, the output value also increases. So if I input a 1 and get a 2, and then input a 2 and get a 3, every time I increased my input and my output also increased, the function itself was increasing. In a mathy kind of way, we would say for all a and b on an interval, as long as a is less than b, then f of a should be less than f of b. When I input a, I get something less than if I input b. Graphically, what that means is the graph is going up from left to right. So I have those 3 representations there. So what would decreasing be then? Well, it would be the opposite. A function would be decreasing is if we increase the input, but the output decreases. So for an interval, if we have a and b again, where a is less than b, if I input a, and then I input b, whatever I got from a should be bigger or greater than whatever I got from b. Graphically, what that looks like is the curve should be going down from left to right. So let's explore this concept through another question. So let's let this function here be increasing or decreasing, but not both. We need to state if it's increasing or decreasing on the interval and justify. So what we're going to do is let's look at the inputs. The inputs are increasing from left to right, so let's look at the outputs. This one here went up by 0.01, this one here 0.03, this one here 0.02, and then this one by quite a bit, that would be 0.23. So every time that the input went up, the output also went up, so this function would be increasing. Let's fix that a little bit. And it's good to get in the habit of justifying your answer. So we'll say increasing because as x increases, f of x also increases. All right, so not too bad, hopefully. Now I'm going to throw a whole bunch of vocab at you, and they're all about the elements of functions. So I got a nice little visual representation to kind of help us out. So let's go in order with a zero. A zero is what we will refer to as the x-intercept, where the curve itself intersects the x-axis. And it's also when the y value, the f of x value, is 0. Domain is a very tricky word. It doesn't seem very tricky, but when we get to talk into detail about it later, you might feel like it's a little tricky. But the domain is the set of all of the independent values that we can use, or x values or inputs. There are times in math where you can't do something. You can't divide by 0, can't take the even root of a negative, you can't take the logarithm of a non-positive number. So those have inputs on what our domain can be. So it's a little bit weird sometimes. We'll get used to it, I promise. Y-intercept is where the curve crosses the y-axis, or when the x value is 0. Our range is all of the possible y values or outputs our function can give us. This one can be tricky, but if you remember what your function should look like, it can kind of help you out a little bit there. Concavity. So concavity could be a new concept for you. It really depends on how rigorous your Algebra 2 class was, but concavity describes how the function's increasing and decreasing rates are changing. So we say that a function is concave up if its rate of change is increasing, and it's concave down if its rate of change is decreasing. This concept might be a little bit weird for us right now because we haven't really talked a whole lot about rates of change, but for now you can kind of think of concave up being a U shape and concave down being, well, the opposite of that, an upside down U shape. And our last major bit of vocab right now is a point of inflection. And a point of inflection is where the concavity changes, where we go from having an up U shape to a down U shape or vice versa. It really doesn't matter. But the moment that rate of change, it's increasing and decreasing, switches, is where we have a point of inflection. So graphically, I tried to label things so you could see it. But yeah, so we're going to apply all of those definitions to this function here. So we're going to use the graph of this f of function below to answer the following questions. So where is the graph concave up? Well, concave up means we're looking for those up U shapes, right? So if I look at this graph here, I can see a nice U shape kind of all along here. And then it switches to be upside down. And then it switches again at this K. So everywhere in green here is concave up. So we would say it's concave up from negative infinity to I, and from K to infinity. Now this notation is a little bit weird. It's called interval notation. You've used it before, awesome. You can kind of skip this part. If you haven't used it before, basically it's a way to describe a continuous interval of numbers from a low end value from a start value to an end value. So in this case, we're saying we want all of the numbers from negative infinity to whatever I is. The U stands for union. It's kind of like or we want all of the values from k onwards and upwards to infinity. Concave down would be the opposite. So where is it? No, that's not what I want. I want, thank you. So it's concave down between I and k at this point. So we would say we're going to start at I and end at k. And we're always going to put the lower number first and the upper number second. Zeros, well, where does it cross the x-axis? It does that at g, and it does it at m. What's the y-intercept of the function? The y-intercept of the function is a. The graph is increasing, so where is it going up from left to right? That's a little bit difficult to see. But if we look at h, starting at h, it starts to go up until it gets to I. Or not I, in this case it's j, my bad. So it's increasing between h and j. And then it goes down again, and then it starts to go back up from L onwards. So from L to infinity. When is the graph decreasing? Well, everywhere it's not increasing, really. From negative infinity to h, and from j to L. So I hope that that wasn't too bad for us. It's a lot of vocab early on, so not a whole lot of problems, a whole lot of vocab, but hopefully that vocab makes a little bit of sense. If we have any questions, please feel free to reach out and ask your questions. Otherwise, I hope to see you in the next video.